We are on Chapter 7, Section 3, still talking about ionic compounds, but we are going to name those compounds and write those formulas for the ionic compounds. Okay, so the objectives for this section: relate a formula unit of an ionic compound to its composition, write formulas for ionic compounds and oxyanions, write naming conventions, apply naming conventions to ionic compounds and oxyanions. Non-metal, remember those are the ones on the right-hand side of the periodic table, and they are elements that are generally gases, dull, brittle, and poor conductors of heat and electricity. The new vocabulary: formula unit, monatomic ion, oxidation number, polyatomic ion, and oxyanion. Main idea for this section: in written names and formulas for ionic compounds, the cation appears first, followed by the anion. So remember, the positive always goes first. Okay, when writing names and formulas for ionic compounds, as we had just stated, the cation always goes first. So you have the positive and then the negative. Chemists around the world need to communicate with one another, so we use a standardized system of naming compounds. Just like we use the SI system in measurement, so everybody is using the same measurement system, we use the same naming system around the world. A formula unit represents the simplest ratio of ions involved. Monoatomic, mono means one, so monatomic ions are one atom ions, so such as the ones in the periodic table. Remember, everything in group 1 has a +1 charge, and you've written these on the top of your periodic table. Everything in group 2 has a +2, everything in group 15 has a -3, and so on. We call those numbers that we actually wrote on the top of your periodic table are called oxidation numbers or oxidation states. This is the charge of the monatomic ion. So everything in group 3 is going to have a +3 charge, meaning it has 3 electrons to share to get to the 8. Let's see. Remember, the transition elements, they're going to have more than one oxidation number, and we will deal with each individual case as we get to them. The symbol for the cation, or the positive, is always written first, followed by the anion. The subscript, the one that goes down below, represents the number of ions of each element in that ionic compound. The total charge must equal 0. Okay, so let's look at what we have here. So we need to determine the formula for potassium and oxygen. So if you look at your periodic table, you can see that potassium is a +1 and oxygen is a -2. These should be subscripts. So potassium with a +1, oxygen with a -2. We know that the cation has to go first, so we know potassium goes first. We know the anion goes second. Okay, our oxidation numbers, our oxidation charges must equal 0. We have 2 negatives on this side and 1 positive. That means for our final answer, we have to have a subscript 2 so that we have 2 positives, which will balance out the 2 negatives. So our final answer is K2O, and it is potassium oxide. Okay, more practice here. Determine the formula for aluminum ions and sulfide ions. Okay, we know that aluminum has a +3 and sulfide has a -2. Remember, we have to have our oxidation numbers need to balance across, so we need to have a total of, I always look at it as like a least common denominator. So it's easiest if you just multiply these two. So 3 times 2 is going to give you 6 positives. And 2, -2 times 3 is going to give you 6 negatives. So you took aluminum times 2, so that's going to be your subscript. And sulfur, you took times 3, that's going to be your subscript. So to balance out your charges, you need to have the same number of positives as you do negatives. So you're going to have 6 positives and 6 negatives. So Al2S3. Okay, you try these. And pause the video if you need to. And here are your answers. Now we're going to look at polyatomic ions. Polyatomic, poly means many, so you're going to have more than one element in this combination. So if you look over here at the ammonium in parentheses, you're always going to keep your polyatomics in their parentheses. It helps to signify that they are polyatomic. So here aluminum is made up of N and then 4 H's, so NH4, and it has an oxidation number of +1. Here is another example. Phosphate has P and then 4 oxygens, so 1 phosphate and 4 oxygens, and so it has an oxidation charge of 3-. Okay, it says over here you can never change the subscript. Okay, inside the parentheses, you can never change the subscript. If you're outside, that's when you can change it. I am going to give you a whole list of these to work with. So just briefly look at this table and then rely on this table and then the worksheet that I'm going to give you. Okay, so let's do a couple practice problems. Calcium and phosphate. Calcium, if you look on your periodic table, is a +2 oxidation charge. Phosphate, notice this whole thing is a -3 charge. Okay, so we have to balance these out. We have a +2 and a -3. We cannot change this 4 down here. So we have to balance out the +2 and the -3, cross multiply them. Calcium is going to be a 3, subscript of 3, that gives you a +6 charge. PO4, there's your parentheses, gives you, if you PO4 to the subscript 2 gives you a -6 charge. So you have a +6 and a -6. Those oxidation charges are balanced out. And here are some practice problems for you. Pause the video if you need to. And there are your answers. Okay, now we're going to talk about oxyanions. Oxy stands for oxygen, anion, remember, is the negative. So these are polyatomic ions composed of the element oxygen. They're going to be bonded with usually a non-metal. Okay, so looking at this table, oxyanion, naming conventions for sulfur and nitrogen. Okay, identify the ion with the greatest number of oxygen atoms. Okay, this ion, you're going to start with sulfate. So you look at the number of oxygens. Down here we have NO3 and we have NO2. NO3 has the greater number of oxygens. That's going to be nitrate. 2 has fewer oxygens, so we're going to call that nitrite. Let's look over here at the sulfates. So we have SO4 and SO3. SO4 has more oxygens, so that's going to be sulfate. Less oxygens, that's going to be sulfite. Okay, so for chlorine, the oxyanion with the greatest number of oxygens, you're going to use the prefix per, the root of the nonmetal, and then 8. Okay, the oxyanion with the fewer, you're going to use the root of the nonmetal and just 8. And with 2 fewer oxygens, you're going to use the nonmetal and 8. Okay, you're going to want to write these down someplace so that you have them to refer to. So if these are all using chlorine again, and you have 4 examples. So you have you have ClO4, ClO3, ClO2, and ClO. Okay, so if we go back up to the chart, the one with the greatest number, you're going to use the per, the root, and then 8. So we have per chlor for chloride, and then 8. With one fewer, you're going to use the root and 8, so you have chlorate. When you have two fewer, which is going to be this one, you're going to use the root and ite, so we have chlorite. And if you have three fewer, you're going to use hypo, the root, and ite, so we have hypochlorite. This just takes practice, getting used to using these. Chemical nomenclature. When you go to name a compound, there is a systematic way of doing it. First thing you need to do is name the cation, the positive, followed by the anion. For monatomic, cations use the element name. For monatomic ions, you use the root IDE. Okay, when you have monatomic binary, when there's two elements, you use, the root name and then IDE. To distinguish between different oxidation states of the same element, the oxidation state is written in parentheses after the cation. When the compound contains a polyatomic, name the cation followed by the polyatomic. Here is a very nice flow chart to follow. Okay, so determine the cation and the anion of the given formula. Okay, so on the left-hand side, we know that sodium is the cation, and we know that PO4 is the anion. Okay, does the cation have one oxidation number? So the cation, does it have more than one? It only has one. So sodium only has one. So yes, we're going to write the name of the cation and then write the name of the anion. So we know we have sodium phosphate. Okay, let's look at this example on the right-hand side. We know we have our cation is iron. We know our anion is oxygen. We know that iron can have at least two different oxidation numbers. Okay, so we are going to write the name of the cation, which is iron, followed by the Roman numeral of the oxidation charge that it represents, and then we're going to write the name of the anion. And we still have just two elements. Okay, so we know our ending is going to be IDE, iron 3 oxide. And I know this may sound confusing now, but you are going to get lots of practice doing this. So let's get to some of the worksheets. Let's do your quiz questions here and then get to some of the worksheets. Oops. Which subscript would you most likely use for an ionic compound retaining an alkali metal and a halogen? Next question. What is the name of the compound CaOH? Okay, Ca we know is calcium, OH we know is hydroxide. So we have calcium hydroxide, but now we need to figure out, do we use this Roman numeral? And the answer is no. That should be C. That should be C. All right, let's get to work so we can get comfortable naming formulas and writing compounds.